Cool. So welcome everybody. Hopefully the homework is going well. How many people have completely finished it already? Okay. Didn't mean to make all the rest of you feel bad, but cool. There's going to be office hours Thursday after class. I'm hosting those, and then Esther's going to. I think Esther canceled her Wednesday office hours. So right now those are the only office hours. If that's a problem for anyone, maybe post on Piazza, and we'll see if we can add extra. But yeah, so just a reminder that assignment 0 is due on Friday at 5. And then the next assignment's going to come out on the following Tuesday, so the next class that'll come out. Cool. Any questions about anything before we get started? Okay, cool. So last time we ended class with an example of cookies, and we did it insecurely. So we're going to just quickly review the idea of cookies again. So the server can set cookies with this set cookie header, and then the browser automatically includes the cookies with every single request. So hopefully this is familiar. So the main idea is that the server wants to do this because it would like to implement the idea of a session. So what's a session? A session is, the goal is, the server wants to keep some set of data about a user, and they want to do that across a series of requests. And this is necessary. We need to do this sort of using cookies because HTTP itself is stateless, if you remember. So we want to tell the browser, remember this key value, and then give it to the server every time. And that'll allow the server to sort of figure out that these requests are correlated. So sometimes some use cases for where we'd want to do this are logins. So if you want to log into a site, you want to be able to browse around the site and stay logged in. Even without logins, you actually might want to have the notion of a shopping cart. So you might not be logged into the site, but there's still a session active because you add something to the cart, and then you browse around the site, you go to a few other pages, and there's still something in your cart. So the server still has some state across these different requests that you're making. And then lastly, this is sort of a nefarious use of cookies. We're going to have a whole talk on this about tracking. And this is sort of a way where you can, a server can tell a browser to provide a cookie every time it contacts an ad server. And you can do, you can basically figure out over time the sites that a user's browsing around on, because every time they contact the same ad server, that same cookie is getting sent. And now the server can figure out it's the same user because they're going to set a cookie that's some unique ID that identifies that user. And we're actually, it's really cool. I got just confirmation from the head privacy person at Brave, who's going to be able to come and do a guest lecture on their sort of defenses against this stuff. So it's going to be really cool. Brave is like on the cutting edge of this stuff. It's going to be really neat to see what they're up to. I think he's employed at Brave, but he's also like a PhD student. So cool. So just to review what the requests look like here in this series of things. So the initial request that a browser makes is going to just be this is an example from last time. So we want to send a post request when the user clicks submit on this login form, and the browser is going to send something like this. You can see there the username and password are encoded in this sort of query style. This is what forms do. This is just what the way forms work, and the server has to parse this out, and then it can compare the username and the password to make sure that they're correct. If they are, then in the response, what we did was, and this is insecure, so don't do this, but this is what we did at the end of class last time. We sent back a cookie with the username equals whatever user had logged in, and also a page. So you can see the HTML right here. So some kind of a page got sent back, and that's what's rendered in the browser. And then all future HTTP requests from the browser are going to have that same cookie tacked on. So this could be 10 or 20 of these. They're all going to have the cookie. However many requests follow will have the cookie. Cool, so hopefully that's all review. Mm-hmm.
This cookie will only get sent to that same server or same host, right? Not all other websites.
Oh yeah, that's a good question. Yeah, it's just the same site, and we're going to go a little bit more into sort of what the rules are around that today. But yeah, I know it would be really bad if this was being sent to every single site. So the key values are only sent back to the same site. Yeah, but there's some trickiness around that. We'll talk about it. But so real quick. So this whole sort of system here, this is called Ambient Authority. This is sort of a security concept. the idea behind this is that we want to so first of all, the idea of access control, right? The whole point is we're trying to regulate who can do which actions on a site. So that's why we want to have like a login system or something like that in the first place. But then beyond that, there's different ways to do it. So if you look back at this thing here, so the reason why this setup is useful is because the user has this cookie tacked on automatically to every request they do, and so they're sort of inherently authorized to do, they're sort of inherently, the server knows that it's them, so they can do anything that the server would allow that person to do, right? They're not like constantly proving who they are via like a username and password in every request, right? So it's called Ambient Authority. So the access control is based on a global and persistent property of the requester. In this case, it's this cookie header that's going to get attached. And so yeah, the alternative to that would be like you can imagine a really, really annoying website to use would be say something like Facebook, where the like button is not just a button; it's actually like a form. You have to type your username and your password, and then click submit, and then that all gets sent to the server, and it will check the username and the password, and if it matches, then it will register a like. Right? That would be really annoying, but that's the alternative to this. So obviously, really useful to be able to do Ambient Authority. There's 4 different ways in general to do this on the web. But cookies are by far the most common. But there are these other 3 sort of more obscure things that you might have seen, in particular IP checking. So this is the idea of just looking at an IP address that's sort of the source of this HTTP request, and then deciding whether to allow it or not based on the IP address. This is used by Stanford libraries to make sure that only people on Stanford campus can access the different journals and things like that. Mm-hmm.
Is it possible to spoof the source IP address?
So that's a good question. Yeah, I mean, so that's actually kind of a complicated question, but in general, not really for TCP connections, which is what HTTP is based on. It's pretty hard because there's a sort of a round trip in order to establish this connection. So you might be able to spoof the initial bit of that, but then when the person you're connecting to sort of sends back the response, it's going to go to the destination that you spoofed, and then they're going to be like, what is this? And they're not going to respond one more time and sort of create the connection. So but yeah, I mean, there are ways to sort of change your IP address. Like you could have a friend on campus who sets up a little server for you. So while you're off campus, you could sort of VPN in through that and then appear like you're coming from Stanford. And that's obviously like that would get around this sort of thing that this IP-based authentication. But yeah, in general, no. Yeah, is any other questions about that? Okay, cool. So then, and this who's seen this third one here, built-in HTTP authentication? Anybody? It's okay, a couple people. Yeah, so it's this really weird sort of username password box that pops out of the browser when you go to a page. It's sort of old, and no one might have seen it by accident or something. It's really kind of jank. And the reason why people didn't, this was envisioned initially to be sort of the way that we do sort of logins on the web when it was created, but it was sort of too inflexible in terms of the UI of it and just the user experience of it. So cookies just were a better option, and that's sort of where everybody went. And then this last one is basically never used. Yeah. Okay. Cool. Yeah. So cookies is basically that's the game that's in town here for sessions on the web. So I want to continue with the demo from before, so we can sort of improve what we got going in that little bank website. So let's see here. Okay, so here we go. Can everybody see that? Are we good, size-wise? Let me know if you need it bigger in the back. Is that a no? Bigger? Okay. Is that better? Okay, cool. Alrighty, so this is what we had last time. So we'll just quickly refresh your memory. We had this password database here that's basically an object that is representing our database. And then we had a couple of routes that we set up. So we had a homepage route, which basically when we visit the homepage, we're going to sort of look at the user's cookie and see there's this cookie called username, and if it's present, then we're going to just assume that is the user, that is enough proof for us to believe that is that user, right? Otherwise, we're going to give them a login form. So then what does that login form do when it's submitted? Well, if we go to the HTML for that, we can just check it out and see that it's going to post a username and a password to this login point, and then what this is doing is just pulling the username out, going into this database and fetching the password, comparing that password to what the user submitted in the request body. And then if it's the same, then we're going to give them a cookie, which is the username, and then redirect them back to the homepage. And now the homepage will, because of what we have up here, the homepage will just show them, so it'll sort of say hi, and it will recognize them. Cool. Any questions about that? Uh-huh.
Can you turn off the light above the projector?
Let's see. Is that possible? There we go. Is that better? Okay, cool. Nice. Cool. Okay, so let's enhance this a little bit. I'm just going to add some kind of private information. So let's add the notion of balances really quick. So every user has a balance. So let's give Alice $500 and Bob $100. Okay. So, and then what we'll do here is just so we have a notion of sort of private information, we'll print out your balance is, and then this is the way you do variable substitution. So I'm going to type in here. We basically want to print a balance, and I guess I'll do that as a separate variable. So we'll make the balance be just balances of username, right? Okay, that looks right. And then I guess we want to probably print a $sign in front of this, so I'm going to add another $sign there. That's actually just going to print as a $sign, even though that looks weird. Okay, now let's check that out. So I'm going to run the server, go to my browser, refresh the page. Let's make this a little bigger. Oops, wrong thing. This one bigger. Okay, cool. All right, so this is our page here. Okay, I'll try logging in really quick. Alice, password. Cool, we're logged in. Excellent, it works. Okay, so one thing that's missing right now is we can't really log out, so I'm going to quickly just add a log out route. So I'll make this a GET request to the URL logout. And what we'll do is, what are we going to do to log out? So, so we need to, I guess delete the cookie is like one way, to make sure that user is going to effectively not see that they're logged in anymore. And this is all silly because this is an insecure system, but this is going to be useful later, so let's implement it. So the way we do this is clear cookie, and this is just going to tell the client to delete the username cookie that we set before. So we need to pass in the name of the cookie that we want to clear, and then we need to respond to them. So let's just redirect them back to the home page when they go to log out. Okay. So let's see. Let's go ahead and refresh this. So I'm still logged in, and I can see here, if I make this a little bigger, we can see here that, oops, that's something else I was doing. So here we have a cookie username equals Alice. Okay, so yeah, I'm going to go ahead and visit the logout URL, and we should see that, okay, I was logged out, and if I refresh this here, there's actually no cookies. So great, that works. Nice. Oh, the request for that? Yeah, sure. What is actually sending? Yeah. It's actually kind of funny. So we're gonna get into this, but so cookies are so old. They're like literally they preceded the notion of like the browser's basic security model, which is called the same origin policy, which we're gonna talk all about next time. But yeah, so they're just old, and they're really jank. So the way that you actually clear a cookie is there's no built-in way to clear it. You actually just you sort of say, I want this cookie to you can set an expiration date on it. So you can say, I want this cookie to last like a year or something. But the way you clear it is, can you think of what you might do?
You just give it past it?
Yeah, you give it a date in the past, and then the browser will see that and can delete the cookie. It's gross, but yeah, it's just what you have to do. So you just pick an arbitrary date, like 1970 or something, and just put it in there, and that'll clear the cookie. Yeah, this is how everything on the web works.
For that, insert place the previous one.
Yeah, so you have to use the same name.
Okay.
Yeah, you basically make a cookie with the same name, and the value can be anything, and then a date in the past. So let's just see it, and we can see what it's actually doing. So I'll type in Alice password. There we go, and then I'll visit the logout URL, and let's see. I'll make sure I'm going to save that. So I'm going to go to the network tab, and I'll just make sure let's clear all this junk out, and then I'm about to hit enter here, and we'll see what happens. Okay, enter. Okay, so log out. It's sent. Here we go. So it sent username equals empty string. We're going to talk about what this is, and then path is 1970 January 1st. That's how you clear the cookie. Yeah, cool. Any other questions? Mm-hmm.
So the browser could just ignore that and keep the cookie
Yeah. In fact, some browsers in the past used to let you sort of configure that as a user preference, like just like never get rid of my cookies. And I don't know what the use case for that was, but yeah, that was a thing. Yeah, there's sort of no enforcement of this in the way we've designed the system so far. Okay, so let's go on. Let's see here. Yeah, so basically the really bad thing here is, like we talked about before, is basically anybody can go in here and just show you, anybody can go in here and just sort of say username equals Bob and refresh, and now we are Bob. Okay, so that's not good. It's really bad, actually. Okay, so what's something we could do to fix this? If you already know like the answer, maybe don't say it. Do you all know the answer already, or? Okay, here I'll suggest something. So what if there was a way that we could give the browser the value username Alice, but we could ensure that value could not be modified? Is there a way to do that? I mean, so in general, you can't trust the browser like we just saw. Anybody can go in and change things. But is there some sort of, and this is cheating if you've already taken crypto, but is there some sort of crypto primitive we could use that would let us sort of fix that value in a way where we would know if it was modified when the user gives it back to us? Come on, I know some of you know this. Okay, yeah.
You could sign the cookie?
Yeah, exactly. You could sign the cookie. So let's make sure everyone's on the same page with that really quick. What does signing the cookie mean? So I have some little just quick sort of review of a primer on signing, but this is not a crypto class. So if you want more on this, take 255, which is great. So we're just going to do a quick primer of signing really quick. So signing is this thing. You have three algorithms basically, G, S, and V. So G is the generator, S is the signer, and V is the verifier. And the idea is, if you call G, you get given these two values that are connected to each other. One is the public key, and the other is the secret key. You also have S. So S is the thing that you actually use to sign a value. So signing a value means that so X is some random value, some string, let's say. You pass in the secret key, and you pass in the value that you want to sign, and you get out this thing called a tag. So the tag is like another random string, but it has some useful properties. So if the user wants to prove that they haven't sort of changed this X value when they give it to the server, they can provide the tag along with it. And then there's this verification function we can use, which what we do is we pass in the should that be SK passed into V? Maybe not PK. No, that is PK. Sorry, yeah. So you pass in the public key and the input X, and then the tag, and that'll tell you, was that tag the same tag that was generated by the signing algorithm? Okay, so what is this all good for? There's two properties that you actually want from a signature scheme. So there's two things that we're going to look for. One is called correctness. This is basically the idea that if we've signed an input with this secret key, then the tag that it produces will, when passed in with that same X input and the corresponding public key, will verify. So it will return accept. It will return true, basically, saying that that is a valid tag for that input. And that should always be the case. Does that make sense? If it doesn't do that, then it's not a very useful verification function. Okay. Any questions about that? Please ask if you don't understand. Please ask. It's okay. Okay. So the next property we want is security. So security just says it's sort of the opposite of correctness in a way. It's the idea that if you create a sort of garbage T, a random tag, and you try to sort of pass it off as a true tag that was generated by the signing algorithm, then the verifier won't be fooled, basically, right? So you try to pass in, like you sort of either change the X or you sort of change the T, and you try to verify it, and accept should basically almost never be true. It's not never going to be true. There's sort of some probability in here, but it should basically be really, really hard, rare that it will ever be wrong here. So in other words, it's computationally hard. Somebody would have to try for a really long time to sort of find a T and an X that would fool this function, right? Okay, so that's probably it's probably enough detail for this, for what we're going to use this for. But before we go ahead and use it, any questions? Yeah?
I don't want to get you off topic, but do people normally use the same certificate for signing cookies as they use for like HTTPS?
No. No. Generally, no. Yeah. Generally, you never want to reuse keys for different purposes, because especially if there's like different algorithms in use, it's like kind of it's hard to prove like what will happen when you do that. Yeah. But okay. So yeah, just to sort of lay this out. So what are we going to use this algorithm for? So we have a client and a server. So there's a browser and our server. And here's how we're going to use this. So the server is going to call G, and it's going to get this public key and the secret key, right? And then the client's going to go to log in, just like it did before. So it's going to pass. It's going to. Why did I do get login? That should be post login because it's a post endpoint. But same idea. So it sends the username and the password. And then the server looks at that and validates it just like it did before. And so say that it is valid. Say that this is the correct password. So the server's happy with it. So this time it's going to do something different than just setting the cookie to Alice, to username equals Alice. What it's going to do instead is it's going to generate this tag where the X that it's signing is the string Alice. Now it gets this tag, and then it sends both username equals Alice and tag equals T back as cookies, right? So the browser's going to remember that. And now let's say the user's going to go fetch the home page. The browser will send both cookies now, and it does it like this. It's a single cookie header with a sort of semicolon delimited key values of all the cookies. And now the server can look at that, and it can run the T through the verification algorithm, and it could say, is this really this Alice not modified, or is this T really the true T for this? And if they both check out, then we get sort of accept back from this function, and then we know that the user has not tampered with the username that we gave them originally. Does that make sense? You look confused.
Yeah, I guess. Why are we using like public and private key crypto here if it's both happening on the server side? Couldn't the server just, since the server already knows its own secret key, it's generated it, why do you need a private and a public key?
Oh, so are you suggesting maybe we could just encrypt it or something?
Yeah.
Yeah, that would work too. Yeah, and so the advantage of this is that the client actually has access to username equals Alice, so the browser could like use this cookie to maybe show Alice's name in the UI or something. Like this is available to the client to see. Does that make sense? I mean, it's not that, you're right, it's not really that useful of a thing. Like you could do what you suggested.
Okay.
But yeah, in the way this is done here, the client can actually see this cookie. This is not encrypted, right? This is completely visible to the client. And that's just sort of what we decided to do.
Okay.
Yeah, but your thing would work too. Your suggestion would work as well. Mm-hmm.
Marcus, is there anything preventing us from just using encryption but still sending back a username cookie?
Sorry, say that again?
Is there anything preventing us to follow Bundle's suggestion, like to just use encryption but also send back a username cookie?
Oh.
What would be the benefit of this as opposed to doing that?
Just like a symmetric encryption scheme as opposed to an asymmetric one on the server side.
Right. I mean, so then you're saying that basically we would get back sort of this unencrypted username equals Alice as well as an encrypted one, and then decrypt it and compare. Yeah, I can't think of any reason why that wouldn't work off the top of my head. Yeah, it might work. Yeah. Mm-hmm.
Just one question I have is, what is preventing us from seeing what the cookie tag is?
Nothing's preventing us, so we actually see it. Yeah, everything that's sent, in this response is going to be visible to the client, and yeah, we can see it, and we can modify it. We can even try and change it, but because of the sort of guarantees that we have with this signing system, we know that there's sort of really no harm to letting the client see this T. Like they can't really do anything with that.
So does that mean if someone else comes along, they see the username and they see the tag, then they can kind of also log in via that method by setting those cookies?
Yeah, you're getting a little ahead here, but yeah, that's a problem. I don't know if everybody caught that, but yeah, we'll get to that in a sec. But that's really good. Yeah, it's really good. You're right. Okay, any other questions before we move on? Okay, cool. So let's try and actually. Oh, wait, I missed the last step. Yeah. So okay, yeah. Then obviously once we verify, then we actually sort of send back. We sort of believe them. We now believe this username equals Alice. We know that it hasn't been tampered with, right? So we can actually send it back to the private page with more confidence. And because it's a cookie, we can sort of repeat this as many times as we want, because this cookie will continue to get this cookie header will continue to get sent with every request. Okay, so let's go ahead and try to do this. So I'm not going to actually use the crypto primitives directly here. For time's sake here, what we're going to do is I'm going to copy the code from the last bit we had, and we're just going to modify this up a little bit, and we're going to use some of the built-in facilities of the this Express framework that we're using here. So what do we want to do? So we want to let's start off by when we initialize this cookie parser here, we now need to, so the way that this works is it's not quite like the G that I showed in the picture. We actually have to give it the secret key that we want it to use, and then it will generate the corresponding public key. But it's effectively the same thing. So what we'll do here is we will pass in a cookie secret variable, and then this is some string that we securely randomly generate. Okay. No one can guess, but that should actually probably be properly generated in a real app. But there we go. So that's our secret key. Okay. Now, so now what we can do is when we actually set the cookie, which we were doing here in the login handler, what we'll do is we'll just add on this little option here, signed equal or signed true, and the framework will handle sort of that for us. All the stuff in the picture that you saw will just handle that for us. So it's going to do that. And then the last thing we need to do is when we actually go to read out the cookie, now we want to make sure that the tag is valid, right? We can't just trust the username because otherwise we're back in the same situation. So we actually need to validate that the signature is correct. And so the framework will again help us there. All we're going to do here is instead of getting the cookies property, we're going to get signed cookies. And it will only add properties which actually properly validate to this. Okay, so if there is a username here, then we know that it had a tag and it therefore was not tampered with, right? Does that make sense? Otherwise, it wouldn't have gotten added to this object. Okay, cool. So let's try this out. Let's go ahead and delete this cookie, refresh the page, and I think I might need to change the server that I'm running because I switched to a different file called server2. Okay, so now okay, there we go. So we're on the new server. So now I'll try the same thing again, Alice, password. Okay, so there we go. So there is an interesting value here. So it's actually a little different than what I showed in the picture. The way that this framework decides to implement the signing is by sort of, I don't know if everyone can see that, but it's basically sort of, you can see that the plain text value of Alice is there, and then all this junk around it is the signature, basically. Does that make sense? So sort of, it did it in one cookie, but it's the same idea. It's going to sort of, when the server gets that cookie, it's going to sort of split it apart and then do the verification. Cool. So I'm Alice. I'm Alice now, right? But now let's try and see if I can pretend I'm Bob. So I'm just going to go in here and change this to Bob, like we did before. And if I refresh, well, the server's not pleased with that, obviously. Cool. And I could also, I mean, it doesn't really make sense for me to change. If I change this back to Alice and I refresh, I'll be logged in again as Alice, which is great. And if I obviously tamper with this tag in any way, like delete, like let's delete a few characters, add a few characters, it's obviously going to also be unhappy with that. Cool. So that's signing. Any problems with this? Can anybody see? You already mentioned. But yeah, do you want to say again what was the problem you saw with this approach?
Oh, you can see the username and the tag, then you can kind of like copy paste it somewhere else, and it will still lock you in.
Yeah. So basically, you're saying that if I actually go, so let's see what you're saying. So let me log in again really quick because I messed up the cookie. Okay, so I'm logged in. Say that I copy this value. Why would this happen? Say I get malware on my computer, right? So I have a virus and it decides to copy off my cookies, right? I realize I have malware, so I'm like, oh, I better go log out from all the websites that I'm logged into, or change my password or whatever. So I go ahead and I do that. So say I log out. I go to the logout URL here. Great, I'm logged out of my bank. Say that I I tell the bank, I call them up and I say, hey, my password wasn't good before, please change it to something else. So the bank goes into their database and they change it to a new secure password, right? Okay, so now I think I'm safe, right? Like I'm like, okay, let me test out my new password, Alice, password 2. Cool, it works. Let me log out and just make sure that the old password doesn't work. Password without the 1 on the end. It didn't log me in, so I'm safe, right? Nope, I'm not safe, because if the malware that stole my cookie just sets username and pastes that old value in and refreshes, they're logged in as me again, right? So I'm basically so somebody who has this string can basically always be me forever. It's bad. It's really bad. We don't want that. When we design these kinds of systems, we want to be able to have the user click a logout link and have it actually like destroy something in a meaningful way, so that session is actually gone, right? Okay. Does everybody understand and agree with that? Okay. So maybe we can try something else. So let's see. What should we try? What's a new thing that we can try here? I feel these weird. What was that?
Have an actual tag function that generates new tags every time.
Have an actual tag function that generates new tags every time. What do you mean by that?
Like, so for different sessions when you sign in, like, I don't know if that's how it works, but can you like generate a new tag to ping onto your username until you sign out again?
Oh, I see. So you're basically saying that there should be some sort of way to, like you're saying, add a number or something to it, and then this.
Or like just change the signature each time associated with the user.
Oh, so anytime a user logs out, the server should change the PK and SK that it's using.
Maybe.
So it could do that, but if it did that, then now when it tries to verify all the cookies from all the other users on the system, it won't think that they're valid anymore because those are signed with a different SK. So I guess it could keep a separate PK and SK for every single user and then destroy it. That actually could work. But someone else had an idea.
Oh no, I was just kind of thinking about the same thing, but I was thinking more along the lines of like a function of time. But what you just mentioned kind of made me think that you'd have to keep a separate SK for every single user, and then just keep track of that, I guess. Oh, like and also change it every single time they were to log in and like start a new session.
Mm-hmm.
I don't know.
Yeah. So you're all sort of circling around a much simpler idea, which is to actually throw out all this signing stuff that I just explained and not use it in this situation. Before we actually here let's actually make it concrete. So what we're all trying to get at is this idea that we want the server to be able to destroy some piece of information that invalidates a session. We can't do that if we're giving them a sort of signature which is sort of trusted forever. So what if we had a database that mapped numbers, sort of ID numbers, to a user that's logged in, and what we do is when a user shows up and proves to us that they are whoever they say they are, Alice, let's say, we pick a number, a random number, really out of a really big space. We call that a session ID number, and then we give that to them. And then we just remember, anytime somebody shows up and presents us that number, we know that's Alice. They present us a different number, we know that one's Bob, right? And then now the user, when they log out, we can just delete that entry from the database. So now if somebody shows up later and presents us with Bob's old number, we're not going to think it's Bob, right? Because there's no corresponding entry in our database anymore, right? Does that make sense? Mm-hmm.
When you need to bind to both the ID and like the username in case they just like manage to get a collision on the number with the ID number?
So yeah, colliding on the ID number is really bad. If they can guess, if they can just sort of try numbers until they find a number, then they can basically assume the identity of that user. That's really bad. Yeah. So we sort of get around this by just picking out of a really large space, and so you could sort of try forever, and you're gonna be hard pressed to find an ID.
How does that make it secure? Since like, if I store the number and there's a malware watching every cookie I have, wouldn't it see the new cookie?
Yeah, so if you have malware on your computer and it steals your cookie, it will be you for however long it has that cookie. The difference between the old system with the signing and this system is that at least if you click logout, then we can destroy that entry from the database, and then that cookie that they have is no longer valid.
But wouldn't they like create a new one and the malware would be able to see, or you're assuming like the malware is like a one-time attack?
Oh yeah. So I mean, if they're persistently on your computer, then you have it's kind of like an out of scope. Like that's like a really hard problem. Yeah. But that is a good point. Yeah, I mean, if you have somebody watching everything you do on your computer, there's not really anything we can do, because then they can just sort of do whatever they want as you. So what we're trying to do here is just create a. I mean, so look, what's a sort of another place where this design makes it more useful. So here's another a case where it's useful. Say that have any of you ever gone to like the sort of security page of your Google account or your Facebook account, and it shows you all the sessions you have logged in elsewhere? So what it's doing is just looking through the database and just saying, for us has these 5 sessions, and you can go in and just delete any of them. So if you like left your computer logged in on your friend's computer, you logged in, and then you left, and you want to remotely sort of delete that session, you can do that with this system, because you can just delete that one entry. And now, so that's not really malware, but this design like enables us to do that, where the old one didn't. Okay. Cool. So let's try to make this better. So I'm gonna copy the code from our first attempt, because I think that was closer to what we want, because it didn't have any signing in it. So we'll go ahead and paste that in here. And so now let's create a new table here called sessions, and it's just going to be an empty object initially because no one is logged into the site. But I'll leave a little comment here that says basically this is going to be it's a dictionary or a map from session ID to username. And so we could actually we can make this a map from session ID to like sort of an object of arbitrary complexity. Like we could store a username in here and like some other stuff, like whatever other things we want to remember about the user. But let's just keep it simple and make it be a mapping to the string that's their username. But we can sort of we can make this as complicated as we want to in a real system. Okay, so we have this sessions object. And now when we go to give them a cookie when they log in, which is in here in the login handler, let's see, here's the line where we're currently giving them a username cookie. Let's change this, and so once we've confirmed that their password is correct, we'll give them a different cookie now. Let's call it session ID. And let's see, what should it be? How should we pick this number? Anyone have any ideas? Random number generator? What would happen if I just, what happened if I did this? Okay, so start at 0, and then let's do session ID, or I guess it should be, next session ID. Next session ID plus equals 1. So we'll give them the number 0, and then we'll mark that the next person's going to get a 1. And then let's see, when we log out, let's change session ID here, delete that. When they log out, and let's see, is there anything else I need to change? Oh yeah, here we need to change something. So when we actually get to figure out who the user is now, we can't. There's no longer a username cookie. We need to change this to get a session ID cookie. And then what are we going to do with this? We're going to, add to the cache? No. So we're trying to figure. So a user showed up. They visited our homepage and they said, here's my session ID. We want to use that to figure out who they are. Yeah, so we're gonna look in the sessions object here, look up that session ID, and then what's going to be the value in there? Well, it's going to be the username, right? So we'll do username equals that. Now it's possible the session ID they gave us is garbage, like it's something they made up. In which case, this lookup here will give us back undefined, and then this if will be falsy, and then we'll go ahead and treat them as a logged out user. So. Does that make sense? Did I miss anything here, or does this look correct to people? Well, minus the obvious issue.
When do you add?
Yeah, you need to add the.
Yeah, so like when do we add session IDs to the sessions?
Oh yeah, good point. So yeah, we gave them a session ID, but we didn't actually remember it. Good point. So let's actually do that. Sessions next session ID equals username. Perfect. Okay. So let's go ahead and quickly see here how this works out now. So I'm going to run the new server and log in as Alice. Okay. Uh-oh. Assignment to constant. What is this? Assignment to constant variable on line 33. What did I do? Oh, I made next session ID into a constant. Okay, let's change that to be a variable that we can actually change the value of. Okay, cool. So it logged me in. What are my cookies? Oh, I still have the. By the way, notice this. The new server, since I'm running it on the same sort of the same domain name basically here, we are getting the sort of old cookie. It's remembered by the browser. So actually, our request to the server includes both of these. But why is this okay? Yeah, the server's just not looking at the username, so that's fine. I'll just delete it to be extra clear here. But yeah, and then here we go. Session ID is 0. Okay, cool. So we forgot one step, didn't we? Yeah, we have a problem. Our logout is something's wrong with our logout function. What's the problem with that? Yeah, we never removed the session, so we have the same problem as before. So if I actually go to log out here, okay, cool, my cookie was cleared, but now like if someone stole that really secure number 0, then they could refresh the page and be me again. So okay, that's not good. So let's actually clear that out of the database here. So we'll do delete. No, first we have to figure out what the cookie is that they sent us. So let's go ahead and do this, and then we have the ID they sent us, and now we're going to do delete sessions session ID. And what this does is it sort of just clears out that key value from the sessions object. So now it's unset. Okay, so let's try that one more time to make sure that works. So Alice, password. It gave me 0 again because every time I save the file, it sort of restarts the server, and my server doesn't have a state. So it's going to start over. Okay, so now let's log out. And what we're looking for here is after I log out, we want this to not work here when I set this value to 0. It should not believe that it's me. Okay, cool. So the session's been deleted from the database. Cool. But what's the problem here? The problem is that, say Bob logs in now, and Bob got session ID 1. Cool. Say that, let's see here, I'll make a new browser over here, incognito window. So this is like a new person, new browser. They can come along here and they can just be like, okay, let's say this is Alice. So let's say Alice logs in. Alice logs in and notices that the session ID that she was given is 2. So she thinks, it's kind of a low number. Maybe there's other users who are given like sequential numbers. What happens if I try a few values? So say she tries, I don't know, she might try like maybe somebody logged in after her. Okay, no one logged in after her. Fine. But maybe she's like, maybe somebody logged in before me. Bob logged in before me. Okay. All right, so somebody proposed how we fix this. What do we do? Mm-hmm.
You could either use a random generator to make it more difficult to guess, or I think you could sign the numbers also, kind of like how we were signing the username before, or do both of these.
Oh, interesting. Signing the number, I hadn't thought of that. So if you sign it, I guess they can't. Yeah, so they can't. Somebody can't just produce this tag now for the number that they're trying to attack or impersonate. Basically, that is true. I feel like there's some problem with it. Yeah.
Why not just like in that sessions database keep the signature, so that way like a signature is only valid if it's valid and it's in the database. Could that work as well?
If it's valid and the signature's in the database. I think that's equivalent to what he was saying. Like, yeah, because unless you're proposing something where, maybe I didn't understand the full thing you were proposing.
No, I mean, it's relatively similar to that, but just like without the extra step of like the session ID, like you can just have you can sign the username, get the signature, put the signature in this session database, right? And then the next time a user sends a request, it's only valid if they have a valid signature and that signature is in the database.
Valid signature and that signature in the database. Right. So.
But the request is only for the session ID.
What was that?
It's going to generate the same signature again if you try to log in later on, even if it's like it's not present in that.
Right.
If you were signing a different number, then you could maybe get around that, but
Yeah, maybe you have a nonce or something.
Maybe. Yeah.
yeah, you have a question?
Yeah, I guess, is there any qualitative difference between like signing a different number each time versus just randomly generating a longer number?
Yeah, so I don't think there's actually a difference. If you pick from a sufficiently large range, then it's going to be effectively impossible for a user to guess. So I think that's like the simplest thing to do. Yeah.
Although going back
Oh,
to the-
sorry.
Oh,
He was first, but it's okay since you're talking now. Just go for it.
You just
Oh.
keep another database of session to IP and user agent, and if the IP and user agent don't match, then you just say no.
Okay, so I like that. That's creative. What happens if? So yeah, that's one problem. IPs can change, especially on mobile networks. So if you're like walking around with your cell phone and then you get a little too far from one of the cell towers, you connect to a different one, you could get a completely different IP address.
Okay.
Yeah, that is sort of a new problem with the mobile stuff. Like that is not a bad idea for desktops, but you still have one other problem with that approach. Can anyone think of what else might not work with using an IP address as the proof of like who a user is? Nats. Yeah, who said that? Yeah. So what's the idea there?
Yeah, basically just like to the public, it's like a bunch of people are actually masking behind some kind of IP, like it's public, but inside they're kind of like sharing their own like local IPs, and like to the public, to the outside, they seem just to be the same IP.
Yeah. So if you have like a home internet connection, you'll have one IP address for the whole house, and all the people living there will appear to the outside world to actually be the same IP address. So if you combine it with the user agent, which is clever, but you still have the problem like two people both running like MacBooks with the same version of Chrome, right? In the same house, then they'll look like the same person. So that's not ideal, but it could work, yeah. But just not, it misses that case. Mm-hmm.
To follow up on the signing versus just the having a random generation thing, I think so going back to my earlier question about public keys and whether or not you need symmetric or asymmetric crypto for it, I think the benefit of signing it would be that then, since there actually is a public key that the server is using, potentially if the user has that public key, you could verify that you're logged into Facebook and not Facebook or something.
I see. That is true.
Yeah.
We'll actually just use TLS for that. Like the browser will just do that for us, but that is true. You could sort of maybe use that for something, but I can't think off the top of my head like what that would give you on top of just using like HTTPS.
Yeah, that's right.
But that is a good point. That is something we do actually want. But we probably don't want to implement that ourselves in our JavaScript that we send down to the browser. Mm-hmm.
Could you have one cookie have the actual like ID or username or whatever you're doing, and then sign the entire cookie structure, like with its expiry and stuff, and as a different cookie?
Possibly. I think we should just move on because there's like an infinite number of ways that we could try to do this thing, but we can maybe talk about that after class. There is just an easy way, which is to, and I kind of misled you all by showing you signing, because now like I know you're all thinking like, how can I use this primitive that I now have to like solve this problem? But there are use cases for signing. It's just not this one. So you can imagine like so signing could be useful if you wanted to say give the user some kind of a promotion. So if they ever buy a product from your site, you want to give them like 20% off. So you want to set a cookie maybe and say like discount equals 20, but you don't want them to be able to mess with that, right? You might want to just sort of sign that value, and then when they provide that cookie to the server, you know that's actually the discount that they got, and they haven't gone into their browser and given themselves 100% or whatever. Mm-hmm.
But unless the attacker can always see the cookie and also use it to get their own discount.
Yes. So that's a problem with that. Yeah. So you could share that cookie with your friend, and then so maybe you put the username in there as well for who the discount is for. But yeah, okay. Let me get off of this signing red herring because I really tricked you all. Okay. So what were we doing here? Oh yeah. So we need to pick a better way to get this next session ID. Basically, that's our problem right now. So we initialized it to 0. So let's just get rid of this entirely. And how about this? Whenever we need to select a session ID to use, let's just do this. There's a function called random bytes. And you give it a number of bytes that you want. So usually in crypto you want like around 128 bits of entropy. So in terms of bytes, that's going to be 16. So we'll just pick that, and then let's turn this into a string because what we're giving back is a buffer, and we want to string because cookies are always strings. Okay, so now and where do we get this function from? We have to import that. So we do that like this. It's just comes from the crypto module in Node. Okay, cool. And this is actually like secure, cryptographically random, good randomness here. So the numbers should not collide. Okay, cool. Is that it? Is that the only change we need to make here? Am I forgetting anything?
Should probably get rid of the next session ID plus equal.
Oh yeah, yeah. That's not going to do anything because and it's also const, so that wouldn't work. Okay, so that's good. Let's delete that.
Should you also check for the case that random number is already given before, like before setting the session's key?
You could.
Check if it exists.
You could, yeah, you could, and it should never happen. Like it should never happen in a really, really long time. But you could throw it in there if you wanted to be sort of extra safe. But yeah, it's sort of not a realistic concern. Okay, cool. Let's try this. Okay, so it's gonna hopefully be better this time. So let's go ahead and let's see here. So I kept it in server 3. Okay, so we're good to go here. So Alice password. Oh, that's an interesting. What is that? Oh, you know what it did? What we did here, we when we two-stringed it, we got back binary string. Let's go ahead and make this base 64 just to make it a little bit easier to read here. Okay. Okay, so that's still ugly. It's okay. So that's our session ID. Excellent. It looks pretty unguessable to me. How do we test it? I don't know. Code looks right to me. Cool. Any questions? We can try logging in as Bob in another window and just see if it looks sufficiently different. Oh, did I get the password wrong? What did I do wrong here? It's Hunter 2, right? Okay, I just typed it in wrong. Yeah, so this looks pretty different. MZ versus that. Questions? Yeah, so this is the correct way to sort of select session IDs. You want to basically, the range of numbers here is so big that you're not going to ever have any overlap. Okay, cool. So if there's no questions, let's go on. So this is like pretty secure. In terms of like the way it's not possible now for users to guess a session ID. They're not going to be able to do that. But there's other sort of implementation issues with this design that we have here. I mean, for one, our passwords are pretty insecure here. We'll not worry about that today. But there's also other problems with the way we're dealing with cookies, and we're going to go into sort of some attacks that you can do with against these cookies. So let's keep going here. So so this is sort of our final implementation. Looks good. So I guess before we do that, I'm going to just quickly just mention sort of why are cookies so interesting. So they were implemented in 1994 in the Netscape browser by one dude, and they were there wasn't that many people writing browsers back then, and the idea for them was described in a really short draft. It wasn't really a spec. It wasn't really precise. It was sort of like a Google Doc that somebody not a Google Doc literally, but here's a thing we could do, and sort of a brainstorm, and then somebody went and implemented it, and that was sort of the standard of like that. Now we have cookies in browsers. There was no sort of formal spec for how they should work for a really long time. There were some attempts made to sort of write down what they should do and sort of how they should work, so that all the browsers could agree and could have the same sort of handling of the cookie header and the behavior with cookies. But one of this is sort of a common theme in web specs is that the people who went to go inspect this out were sort of overly ambitious, and instead of just describing the existing behavior in like the most popular browser of the time and just sort of trying to get all the browsers to agree on at least like doing the same thing, they sort of got a little bit over ambitious and sort of said, well, what if we could also sort of change all these other things and sort of make it a lot nicer? What if we added this and we added that? And because of that, the spec sort of wasn't describing reality, and so therefore it wasn't really serving its purpose of trying to unify the behavior across all the different browsers. And so basically people ignored it. And then there was another attempt made in 2000, and this one was also had the same problem. It was called Cookie 2, and it was really ambitious. It tried to sort of fix all the problems, and everyone ignored it. And then finally, in 2011, a group of people actually wrote an RFC that the browsers actually follow, and that is sort of just describes the way the cookies work. So the inconsistencies between browsers are not as bad as they used to be in the bad old days, but because of sort of the way that the design was developed in a very ad hoc fashion, it's like kind of just a really gross spec, and it doesn't really make sense in a lot of ways. In particular, when we talk about same origin policy, we'll see that the security model for cookies is actually completely different from the security model of everything else on the web. Like cookies are just this weird special case that just behave differently, and it can cause a lot of problems, as we'll hopefully see. Okay, so cool. So cookies, they have a few attributes you can add to them. We mentioned already expires, so you can say when you set a cookie, I want it to expire on this date. If you don't specify a date, then they last for as long as your browser session is active. So the idea is if you close your browser, then the browser will delete the cookies. In practice, though, in practice, what actually happens if you don't set the expiration date is that browsers later on added this thing called session restoration, which is I don't know if you've ever had some text in a form and then you close the tab by accident and you're like, oh my god, and then you reopen the tab and the text is still there somehow. So the browser is like sort of saving all this extra session information, sort of like in a way that the web, sort of the specifications for the web don't really say. Like that's sort of an add-on kind of thing that the browser is doing to make your life easier. And in the case of these sort of session cookies, when you close your browser and reopen it, oftentimes it'll still remember that cookie that was supposed to be cleared at the end of the session. So if you want a cookie to actually be cleared, you should actually set a date. You can't rely on the browser to actually do it for you when the user closes their browser. But okay. So then there's this other attribute called path. So the idea with this is that you might want to set a cookie that only gets sent on a particular path. So say that you have like I don't know, like a blog, and it's it's hosted on example.com/blog, and you might want to log into that and set a cookie that only gets sent to the server when you're on something that starts with /blog. And if you're on a different part of the site, like I don't know, chat or something, then that cookie won't get sent because the chat system doesn't need that same cookie. It has a different cookie or whatever. That was the idea. Is you can sort of scope these cookies to only be sent in certain cases. So here's an example. If you said path equals /docs, then the cookie will get sent whenever you're on a page that's like /docs or also /docs/web and so on and so forth. Anything that sort of basically starts with that prefix. Cool.
For the first one, could you repeat what exactly session in the second sentence means? No date and last session.
Yeah, sorry, because we already used the word session to mean a completely different thing. So session, so session in this context means literally like sort of the user's time interacting with their browser. So when they close it, like that's the end of their browsing session, and then the cookie would go away.
Okay. So can we trust browsers to at least do that, or
no? No, they don't. Yeah, they don't really, because of that restoration behavior that I mentioned.
Okay.
Yeah. Okay, so there's a big problem with this path idea. It's completely broken, actually. So you can't rely on it to not actually you can't actually rely on it to isolate cookies. So if you say path equals /docs, a different page that's completely different, say different organization in your company or something has a different URL, they can write code that will sort of pull the cookies from these other paths. The path system in cookies it doesn't work because it was designed before the actual security model of the web. So we'll talk a little bit about why that is. in a sec. And I'll show you an example of it actually in action. Okay, so there's another attribute called domain. This one lets you scope the cookie to a domain broader than the domain that returned the header to you. So an example of this would be, say that you visit login.stanford.edu and you log in and it gives you a session ID just like we did in our example earlier, and that's actually what it does. It gives you a session ID cookie. Maybe what they want to do is they want to allow stanford.edu to also see the cookie. So they could do that by saying domain equals stanford.edu. If they didn't do that, then by default what would happen is the cookie would only be available to this subdomain and subdomains which sort of branch off of it. So you could have hello.login.stanford.edu, that could see the cookies from login.stanford.edu, but stanford.edu can't. So if they want to fix that, they can sort of say domain equals this, and then now it's sort of anybody on stanford.edu can see that cookie, and it'll get sent with all the requests. So anyway, this is something you probably don't use very often, but it's just a thing to know. So how do you actually attach these attributes? You just sort of tack them on after this sort of the semicolon. So you set cookie, semicolon, and you sort of tack on these extra attributes. If you want to set multiple cookies, by the way, don't be confused. This is not a cookie called expires equals whatever, right? To set multiple cookies, you actually have to send multiple of these headers. So you would add multiple set cookie headers. It's weird. Okay, so yeah, we talked about setting the expires header to a date in the future. So it used to be that Google would set their cookie to last until the year 2038, which creeped a lot of people out because they're like, why is Google wanting to remember my computer for that long? So at some point they actually switched over to just keeping it for 2 years. But yeah, it's not really necessary to do that because what you can do is you can just set it to be like a month or two in the future, and then anytime the user comes back to your site, you can reset the cookie to a new date 30 days in the future. So there's really no need to be so aggressive. Yeah. And as I mentioned, you delete it by doing a time in the past. We already talked about this. You use the same name and then you just pick a date in the past. Okay, this is where it gets really weird. So the way you access cookies in JavaScript is literally the most ridiculous API I've ever seen. So here's how you set cookies. So you do document.cookie equals name equals Frost. Let's say that's a cookie, right? So I can set cookies from JavaScript, and then those will get sent on all future HTTP requests. But if I want to add a new cookie, this does not actually overwrite the old cookie. This adds a new cookie. It doesn't look like it, but that's what it does. So if I actually get the value of document.cookie, it's now going to be this semicolon delimited string of all the cookies I've set. This is one of those things where it was done this way in the early days of the web, and we've never been able to change it. It's just bad. And then to remove cookies, this is the API to remove a cookie. Yes, that's the API. You might want to ask, well, how do I look up a cookie? Like, say I want to look up the favorite food cookie. This is not an object that you can just use to look up the cookie. No, you have to write a regular expression to pull out the value. Yeah, yeah. So this is really gross. But there are libraries you can use to make this slightly easier. But yeah, there we go. So this deleted the name cookie, and now when I pull up the cookie, you're going to see it's just favorite food here. Okay. Cool. So go onward. So let's talk about an attack. So we kind of mentioned it before, but if you steal someone's cookies, you can basically be them, and that's an attack called session hijacking. So one way this happens is if you're not using HTTPS, then somebody who's watching your traffic can take your cookie because it's just there in the open, in the clear, and then they can use it to impersonate you. When they send the cookie to the server will be fooled and think that it's you. So that's called session hijacking. This is a pictorial representation of that. So the client sends a request to the server with a session ID equals 1234 in this case. And normally what would happen is the page would come back to the client containing the private information, and all's good. But in the sort of model we're talking about here, where you do the session hijacking attack, what you have is an attacker somehow sees this request, and because you're not encrypting your connection, and they can then send the same request to the server that the client originally sent, and now they're going to get back the same private web page. They're effectively logged in as you, right? So this is sort of textbook session hijacking attack. So what's the or actually here, before I ask that, this is a really, somebody mentioned this in, I think, last week, but this is a crazy thing that happened in 2010 where somebody made a Firefox extension which would, it would turn on your network card and put it into this mode called monitor mode or promiscuous mode. I don't know, there's two variants of it, but anyway, what it effectively does is it sort of disassociates you from the Wi-Fi network that you're connected to, and it just looks at sort of all the traffic that's going by, basically. You can also do this if you're plugged into to a wired connection. Basically, all the traffic that's happening on the local network that makes its way to your computer that's not actually intended for you. You can look at it, and if it's not encrypted, then you can just see people's cookies right in that traffic, right? So what you could do is this is like what would happen if you went to Starbucks and you just got on the Wi-Fi. All the other traffic from the people around you was going to Facebook at the time was not encrypted. And you could, this extension would just notice those requests and pull the session ID out, and then present it to you in this beautiful UI. And you could literally just click on anybody, be them, and just be logged into their account. It was ridiculous. Yeah, it was really wild. They did this sort of as like activism to sort of tell everybody like, hey, it's ridiculous that you're not using HTTPS in 2010. Like, please add HTTPS to your site. At the time, it was like really common for people to just put HTTPS on their login form, because the idea was we don't want people to see the user's password, right? So we encrypt that. But then once we give them their session ID, then all their future interactions with the site can just be unencrypted because their password's not in those requests. But like the session ID still is, so it's like pretty bad. You can be them and do whatever they would do. So it's not a solution. But yeah, this was really wild when this happened. Does anybody remember that besides the person who mentioned it last time? Yeah, it was a little while ago, but yeah, it was really crazy. Okay, so yeah, that doesn't really work anymore. Okay, so obviously, like we talked about using HTTPS to fix this, but there's another thing you can do, which is you can sort of, when you set a cookie, you can say, never let this cookie get sent over an unencrypted connection. And the idea there is that you say that your site sort of still has parts of it that are not fully encrypted. So you have some pages that are in HTTP and some that are in HTTPS. If the user visits the HTTP version, you don't want the cookie to get sent because it will be in the clear, right? So this says, like, if that somehow happens, just don't send the cookie, please, because I would prefer that they like are logged out or whatever than that their cookie is sent in the clear and somebody could hijack their session, right? The correct solution here is to just use HTTPS across your whole site on every page, and then this is not even an issue, because then your cookie your session ID can never get sent in the clear. But this is something to know about. Any questions about this? Okay, cool. So this is something we're going to talk about next time in much more detail. But so what if an attacker can somehow run their code inside of a website? So somehow they get their code running in the context of the page of some other site. So like what could they do? Well, one thing they could do is steal the cookie. So because we know that the full cookie is in this variable here, one way to exfiltrate the cookie is to basically create an HTTP GET request to some URL. And a really easy way to do that is to just make an image and set the source to this. And then what this will do is it'll tell the browser to basically kick off a request to this URL and to fetch the response, and then to basically prepare to show it as an image in the page. We didn't actually add it to the page here. But if we did, it wouldn't work because this is presumably not actually going to serve an image. It could, but it doesn't matter because the point is that this request makes it to the attacker's server and the attacker sort of gets the cookie. But we'll talk more about this. This is just sort of to let you know that the cookie is so sensitive that we sort of, this is sort of like a worst case scenario is if a user's cookie gets exfiltrated in this way, then now the attacker can basically just set their browser to use that cookie, and then they're that person, right? No matter how good you do your session IDs and like the stuff we talked about earlier, this will still bite you.
So when a code has document that cookie, so what you're saying is it returns all the cookies that are like in the browser, not just specific for that.
No, just specific for that site. Yeah. So the idea here is that this code is actually running in, let's say example.com is your site. If somehow the attacker got this line of code into the page, into your code somehow, then every user that's logged into your site and visits your site will now be running this code, which basically sends the cookie off. We'll talk about how you actually, as an attacker, get this code into the site next time. But this is like sort of just a thing that you could do with cookies to steal someone's session. And we'll talk more about it next time. Yeah, but one thing you can do to sort of defend against this is it's worth doing if it works for your web application, is you can basically tell the browser, I want the cookie that I'm setting now to never be made available to JavaScript. So what does that mean? That just means that basically that document.cookie API just doesn't work. It doesn't return your cookie that you've added HTTP only to. So this becomes a cookie which gets tacked on automatically by the browser to the in the headers anytime a request goes out, but the JavaScript can't see it, right? So this protects you against that scenario where the attacker is running code in the page. Does that make sense? Okay.
So one of the cookie examples that you had earlier was theme equals dark.
Yeah.
So if you use this HTTP only, does that mean like, because my understanding is theme equals dark, but there's probably like a JavaScript thing.
Yeah. So that would be if I was hoping to have my JavaScript on the client side in the user's browser, look at that theme equals dark variable and figure out what to do based on it, then this would not be the thing to use. Yeah. But in that case, that's not really a sensitive thing, so I almost don't care if that's available to JavaScript. So I wouldn't use HTTP only for something like that. Yeah. In fact, honestly, that's not even really a good use case for cookies. Theme equals dark is just sort of an example, but yeah. Any other questions about this? Okay, cool. So so this is the thing I mentioned earlier about how path is sort of a lie. So remember, this is the thing that lets you say, I only want the cookie to get sent to a particular URLs that start with a particular path. So it doesn't actually protect the cookie from unauthorized reading when it's on a sort of related URL. I'll show you exactly what I mean by that in a sec. So here, actually, let's just do it. So, okay, so what I'm going to do here is I'm going to pick a victim site. So what are we going to pick here? Let's pick on 106A. Because they are just learning how to code, so they probably have some bugs in their site. Okay, so this is a little bit contrived because they actually don't have any kind of login functionality on this page here. But let's say that let's just say that there's some code that ran that does document.cookie equals I don't know, session ID equals 1234 and let's say that they're paranoid, so they know that if they were to just set their cookie like this, that any sort of page on web.stanford.edu would be able to see this cookie, right? And they're worried about that because they know that CS253 is hosted on the same URL, and they're worried about that, understandably. And so they're going to do this. They're going to say, okay, path equals /class /CS106A. Yeah. So actually, let's just go with that. So they're going to set this like this, and then let's check document.cookie and just make sure that was set. So yeah, we have one cookie. It's session ID equals 1234. And you'll notice that the sort of metadata about the cookie is not included when you look it up, but it is actually stored in the browser. We can check that out by going here to the application tab and just making sure that it's kind of cramped here. But how do I see? Basically, domain path. There it is. So this cookie is sort of only supposed to be sent to class /CS106A. Okay, great. So how can I get around this? So let's say I go to CS253. So completely different site. So if I check document.cookie, what do we got here? It's empty. Okay, so the browser seems to be doing its job. It's not providing the cookies to this sort of separate path. But there's a way around it, which is that because, well, I guess we'll talk about the same origin policy we'll sort of explain in full, and that's next time. We'll explain in full sort of exactly why this works. But let's just show you how it works, or like how to actually do it for now. So what we're going to do is create an iframe, which is a little window to another page, and we're going to add it to this page. So we're going to create a little window that contains the 106A page and put it into our page. Okay, and we're allowed to do that. That's totally like sites can do this to your site. So you have to be sort of prepared for this. Actually, that's a thing that can happen to your site. That somebody can put you in a little box in their page and then move that around or do whatever they want. So in this case, yeah, we're going to make the iframe. Now, nothing's actually changed in the page because I haven't added it to the page yet. But before I do that, what I'm going to do is set the source of the iframe to be what was that URL? It was, I want to just get the actual URL. So here we go. This is the URL. So I'll copy. Actually, let me just check one thing really quick. Yeah. Okay. Cool. So so I copy the URL. I'm back on 253. So here's the URL. That's now. Wait, what? What just happened? Did I not name it iframe? Okay, let's try that again. I'm not sure what happened there. So I'll make an iframe, and then I'll say iframe.source equals the 106A URL. Okay, yeah, I don't know what happened there. But anyway, so now we have an iframe, and it's set to the 106A site. And now I'm going to add that to the page. So I'm going to do document.body, which is the body tag, and we're going to append the iframe. Okay, so there it is. Beautiful. So now, okay, one thing we can do too, if we want to be particularly fancy here, is we can do, we can hide it. So this would all run in an instance. The user wouldn't see that we're sort of, there we go. So it's there, but it's invisible. And so then what we could do is we could then use our reference to the iframe. And so we have this iframe here, right? What can we do with it? Well, there's a property on it called content document. This is effectively, you know how we have a document variable here? This is the document variable of that page. That's the document variable for the 106A site. And we are allowed to actually access that. So we are allowed to cross that iframe boundary. That is like I mentioned, we'll talk about the same origin policy. It allows us to do this. So we cross the boundary, and then we pull out, what are we going to do? .cookie, right? Document.cookie, but for the iframe. And there it is. So we're allowed to read their cookies. That mechanism, doesn't work. So yeah, and again, this is because of the sort of disconnect between the way cookies defined sort of their security model and the true security model for the rest of the browser, which we're going to talk about next time. Cool. So yeah, this is something to really know about. Yeah, sure.
Well, let's see if that iframe contained facebook.com.
Mm-hmm.
So you wouldn't be able to do that, right?
Right. So I was allowed to do that because I was also on web.stanford.edu, and so the browser allowed that.
Is
Yeah.
that like how iframes work?
That's actually just how the whole security model for the web works. I feel like I previewed it a little bit here. I should probably just put in an actual explanation of it because it's really not that hard of a concept. But we're going to talk about that first thing next time. But basically, it comes down to the browser looks and sees if the domain name is the same, the port is the same. In this case, we didn't really use a port. It was port 80, the default. And if the protocol is the same, which is HTTPS in both cases. If those three things are the same, then you're allowed to effectively do whatever you want with the page. You can manipulate it however you want. You can reach into its context. You can change its DOM nodes. And that's the same origin policy. So if those are different, then you're like, you have to stay at sort of arm's length. You can't really manipulate the page. And that's why we were able to do that. So the whole, the path thing is going to protect us, it's going to keep this cookie isolated is really not true because we can just go in and run our own JavaScript directly in the 106A page. I wonder if there's actually there may be some security issue because of this, because basically all Stanford sites are on web.stanford.edu in different folders. So I don't know, I haven't actually looked too much into it, but that might be a fertile place for looking for problems if anyone's interested. Yeah.
Does this work in subdomains? Because like if you think about Slack, they use like the name of whatever Slack channel you want, and then like that's like the
Yeah, so with subdomains, those are treated as different host names. So that triple I talked about, the protocol, the host name, and then the port. So that would be considered different. Yeah, that's actually a good way that's a common way sites actually do create isolation because when they want that they'll just make a subdomain. Yeah. Okay, so I don't think we have time for the rest of this. We'll just maybe do this next time. So that's it. Yeah. Thanks everybody.